food talk. I hope you enjoyed that topic on isotope ratio, something very different on food authenticity. Okay, the last speaker we have, the last talk of the day will be by Dr. John Gilbert, and the topic will be managing a food testing lab. John?
The talks you've heard today have focused mostly on analytical techniques and methodologies. I'd like to finish the seminar today looking at a different aspect. I'd like to talk a little bit about business issues relating around laboratories. So we're talking mostly about cost issues and investment issues. So the outline of the talk, first of all, is to look at a little bit about different types of food testing laboratories, look at some of the factors that are important in terms of food testing, then discuss some issues related to reduction of costs in terms of running the lab. I'll look at a couple of examples of cost-benefit analysis. I'll talk a little bit about the Food Safety Response Centre we have in Dreieich in Germany, and then conclude by talking about investing for the future, which is really how you maintain a state-of-the-art laboratory in the analysis area. So we've divided up the food testing laboratories into three categories. They're somewhat artificial distinctions, but you'll see in a minute where this categorization has come from. So we've firstly got what we call in-house laboratories. These could be state institutes, they could be industry laboratories or reference laboratories. And this type of laboratory has an internal customer. So the customer is part of the same organisation. So the person asking for the analysis is part of the same organisation that's doing the analysis. This is the in-house laboratory. We've then got independent testing laboratories, private laboratories, contract laboratories. And these are offering their services in the marketplace. So they're laboratories that are operating as a business, effectively. They're selling their analytical skills, selling their ability to analyse food samples. And then finally, we've got the university sector, which sits somewhere in between them. Some of them are doing some service delivery work. The reason we've divided them up is because there's some characteristics about laboratories, and you'll see where this is going to as we get deeper into the talk. One of the characteristics is the use of validated methods, accreditation to ISO Guide 17025, demonstration of efficiency, so performance and efficiency testing. And these are quality aspects of a laboratory. You can see that government labs are very strong in these quality aspects, as are the contract laboratories. If you're operating in this environment, you have to demonstrate the quality of the data that you're generating. They're very, very strong in these areas. The universities really are not very strong at all. You won't find university labs that are accredited. You won't generally find them taking part in efficiency testing. So this is not a strength of the university sector. Most customers are interested in speed of analysis. How quickly can I get my results? When can you send the results back to me? So speed is a very important consideration. And the contract labs focus a lot on getting results out quickly, getting results to customers when they'll say they'll get them. Price is another important consideration. If you're operating as a business, you're competing with other laboratories, and price is very critical. The government labs really tend less to be focused on speed and price. They're more focused on quality and everything else. Where the universities are really strong is in the area of innovation. This is where the new technologies are coming from, the new methodologies, the new approaches to food analysis. So the university is contributing here. Contract labs and government look to the universities and You often see transfers of technology from universities into these sectors. So some of these characteristics I've mentioned are adding to the cost of doing analysis. So in-house method validation, which is essential. If you're going to operate a service, you have to validate the methods. It will take you a minimum of 15 days to validate a method. It depends on the matrix, depends on the analyte, and it depends on the degree of sophistication of the analytical method. If you want to do a full laboratory validation, I mentioned this morning, it can take a year. It's a very slow process. So validation is slow and expensive, but it's essential. You need to validate methods. Accreditation is also essential. You really can't operate as a private laboratory unless you're accredited to 17A. The problem with accreditation is it adds to cost. So there'll be a 20% plus cost of setting up accreditation if you're not accredited. There's an ongoing annual cost of accreditation. 10% of your running costs might be spent to maintain accreditation. One of the additional problems, apart from the cost, is that accreditation can be very prescriptive. It can start to get excessive. As a manager of a laboratory, one of your jobs is to make sure that accreditation is fit for purpose. Make sure accreditation doesn't become so excessive it's adding additional cost without adding any value. So you have to keep an eye on this. The other issue is around maintaining flexibility in operating the laboratory. More and more accreditation assessors are requesting things from the laboratory, and all of these things become restrictive in terms of the way you can operate. There's two ways that, in fact, you can both maintain accreditation and also maintain flexibility. One of them is to have what we call a generic scope of accreditation. And this means that rather than having each and every individual method accredited, you seek accreditation for a technique. So it's generic, it's for a technique rather than for a specific method. So here we might have accreditation for PCR. We may have accreditation for the use of PCR in GMO testing in food. So rather than having a SOP for detection of soybean GMO or corn DT, you'll have to seek accreditation for the technique. The other possibility is to seek accreditation for LC and SMS for veterinary drugs or for pesticides. So the generic accreditation gives you much more flexibility. The other issue that frequently arises is when there's a scare. There's a food scare for melamine. As a contract lab, you want to be offering analytical services for melamine. But the customers say, I want to buy your services, but you're not accredited. And it can take 6 months to get an extension of scope through the normal way. So what you do is to have a flexible scope of accreditation. And here, you're having a validation protocol accredited. And provided you follow that validation protocol, you can rapidly claim accreditation for a new analyte. And then later in the year, when you have your next inspection or surveillance visit, you formally extend your scope. So 2 ways in which you can have additional flexibility within the framework of 17025, which is one of the business issues if you're running a lab competitively. If price is an issue, and it is an issue in food testing, you need to keep an eye on a number of things in the laboratory. One of them is to make sure that instrumentations and methods are fit for purpose. It's very tempting to move all of your methods to very sophisticated instruments, to use LC, MS, to do everything. But of course it's a very expensive instrumentation. There's a lot of pressure on the availability of the equipment. So making sure that you use the most appropriate instrument for the most appropriate measurement is important. If you can do the measurement by HPLC with fluorescence detection, don't do it by mass spec. So making sure method and instrumentation is fit for purpose. simple things like minimising the cost of consumables can have a big impact on cost of analysis. If you can reduce HPLC mobile phase solvent costs by half by using low solvent flow rates in UHPLC, can have a big impact on the cost of that analysis. Minimising calibration, doing the minimum necessary, not doing a 12-point calibration if a 3-point calibration is sufficient, again reduces the cost. Looking closely at failure rates in the laboratory, sometimes you find that batches of samples are failing repeatedly because they're not meeting quality standards. Every time a batch of samples fails, it means the cost of doing that analysis has been totally wasted. You can't charge the customers for sample batches that fail. So very low failure rates are really important in maintaining efficiency. Improving speed of analysis. The faster you can run an instrument, the more samples you can run and pass through that instrument, the more effective use you're making of an expensive investment. So fast analysis improves efficiency. Minimising instrument downtime, perhaps by having preventative maintenance rather than waiting until instruments fail, particularly critical times in the laboratory can be important. And automation, we've heard already today about turbo flow technology. But we've discussed the turbo flow very much from a technical point of view, in terms of the technical advantages of using turbo flow. What I'd like to do is look at the cost benefit of this automated system. And this example is the analysis of the veterinary drugs, the fluoroquinolone antibiotics in honey. These substances are not permitted in honey, so a large company manufacturer supplying honey to the marketplace needs to test routinely honey for the presence of these antimicrobial agents. This is a real example from a company that tests 25,000 samples a year, so it has a very high requirement for testing. And we've compared on this chart the cost of conventional analysis with the cost of using the TurboFlow TLX system. So in conventional analysis, you're using disposable cartridges, so you can only use the cartridge once, and it's costing around $2 per cartridge. Using the TurboFlow system, the cost is $500, but you can use that column 400 times. So immediately, the cost per sample, simply for the columns, drops from $2 to $1.24. The cost of 25,000 samples drops from $50,000 to $31,000. Solvent costs are roughly the same with both systems, but you're making a big saving in labour costs. So with the automated system, the technician is spending about 15 minutes per batch of samples. With the conventional system, it's taking 2 hours. So you're getting a saving on labour costs. Total saving is coming down from a cost of $110,000 per annum down to $47,000. If your investment is around $50,000 in the automated system, it means you have a payback period of around a year. This is the sort of cost-benefit analysis that's necessary when you're making a business decision to make a purchase of a system like this. And this is really a no-brainer. It's quite obvious with large sample numbers that you have a very rapid payback in investing in this sort of technology. You can see more clearly why you're getting such a saving. This automated system is very simple. It's a matter of dissolving honey in butter and then putting it into the system. Everything else is automated. In conventional analysis, there's a lot of different steps, including cleaning up. There's 4 steps here before you do the analysis. So you can see the huge benefits in using the TurboFlow system. Another way in which you can make quite big savings in the laboratory is by making more effective use of expensive instrumentation. So in this example, we've got an MS system, SMS, and for this analysis of nitrofurans, there's only 3 peaks in the run, and these peaks emit over 3 or 4 minutes, but the total HPLC runtime might be 45 minutes. And what this means is that the instrument is only being used for 3 or 4 minutes, although it's effectively tied up for 45 minutes because you can't start the next analysis until you've completed the chromatographic run. Now, in this system, we're coupling 4 HPLCs to the same detector. So the first HPLC system eludes the peaks of interest in the mass spec detector. Immediately after the last peak is eluded, this column switches to waste. The next system then switches in, and we made measurements for this time window here. This then switches to waste. The third system comes into operation, and then the fourth system. So you can see in this example, by using a very simple column switching technique, we're analysing 4 times as many samples with the mass spectrometer as we would if we had a single HPLC system coupled through. This is only cost effective, again, if you have large numbers of samples to analyse, but in many of the food safety programs, you do have large numbers of samples. You can increase productivity here by a factor of 4 using this column switching technique. The processes in food testing laboratories have become very, very complex these days. So that a typical laboratory will receive large numbers of samples every day. Different samples require to go to different points in the laboratory. They perhaps come in during different times during the day. Managing this is a complicated process. You need to maintain full batches of samples. If you analyse a batch of only 10 samples when you can analyse 20, you're increasing the cost per sample because you've got calibration samples and blanks in that batch, because you've only got 3 samples perhaps that you're going to charge the customers for. So maintaining full batches of samples is important. Planning sample workflows through the lab is important. Some samples will need screening before they then go on to confirmation. Some samples will go for multiple analytes. You may be doing pesticides and mycotoxins on some samples. With modern instruments, we're generating huge amounts of data that need to be processed. And at the end of the working day, at the end of the week, we have to report results to customers. We have to generate reports. We have to generate certificates. So there's a huge complexity in the laboratory in terms of the way we manage all of these processes. And one of the ways we can gain enormously in efficiency is to control this through essentially a complex data system. And this is called a Laboratory Information Management System, and the one that Thermo market is the Nautilus LIMS system. The one I'll talk about is called LIMS on Demand. And the LIMS on Demand system provides sample tracking. So when the sample arrives at the laboratory, it's barcoded, so it's given a unique barcode number which can be recognised easily by scanning throughout the laboratory. So you don't need to transcribe information about the sample. Once it's barcoded and it's entered into the system, it's a unique sample. There won't be any errors in the laboratory by somebody muddling that sample with another one. It's automatically recognised throughout the lab through sample tracking. When the samples are analysed, the results are immediately associated with that unique sample number. The results can be calculated automatically. You can enter calculations and formulas into the LIMS system, so that laborious process of calculating results is taken care of automatically. The LIMS system can be configured to generate certificates or reports automatically as well. So many of the things that are very, very time consuming take place automatically with the LIMS system. This is an example of a laboratory. It's not a food testing lab, but it could easily be. It's a lab doing DNA testing. Typically 300,000 samples each year are analysed, generating over 21 million individual DNA results. And this lab had a turnover of 110 New Zealand dollars each year, and the saving moving from manual manipulation of data to LIMS resulted in $1 million saving each year. I don't know what the investment cost is, but it's very easy to see the business case for a LIMS system because it's not difficult to make stables like this which are not insubstantial. So LIMS on demand is a little bit different from normal LIMS systems. You don't purchase a capital investment to purchase the LIMS system. You're effectively leasing or renting through a monthly subscription fee. So you don't have to make a big capital investment, a monthly leasing fee. This has a number of advantages. The data is stored externally. You're generating huge amounts of data. The data security is guaranteed. It also has a big advantage if you're working as a multinational company. If you visit a customer in another country or even in your own country, you want to discuss results, you can access those results with a web link to the database. So you don't have to print out data and tables. It's accessible wherever you are in the world. There's automatic backup of data, automatic updating of software. So you don't have to worry about these. So it's very easy to manage the cost because there's a simple monthly leasing fee to access this LIMS system. The other benefit of LIMS is that it provides an enormous resource to the quality assurance manager. So it's supporting accreditation activities. When you have a surveillance visit for an accredited laboratory, typically the assessor will say, I'd like to see the results for this sample, and this sample. These samples were analysed 6 months ago, 9 months ago, 3 months ago. And you have to find the raw data, you have to find the calculations, you have to demonstrate to the assessor the validity of your data. And you can imagine in a laboratory that doesn't have a LIMS system, somebody has to go and try to find where the laboratory books were stored, where the hard copy data was stored. So the LIMS system provides very rapid ability to assemble and collate raw data and show it to the assessors. It can also mean that in a big laboratory, many labs now employing several hundred staff, it means that data can be shared by staff within the laboratory by online access in the offices. So a very important resource to support accreditation as well. One of the costs that you have to manage in running a laboratory is staff time. Time is a very important resource. Time management needs to be managed. You need closely to monitor how staff time is being spent. You need to look at ways in which you can make more efficient use of staff time. And where that might came from, we would produce monthly utilisation records. So for every member of staff, you produce utilisation charts in terms of the numbers of samples and the income that those staff have generated in the laboratory. Many things are important in effective running the laboratory. I put this slide together just to demonstrate that sometimes very, very simple and obvious things can have a big impact on profitability and efficiency. If staff responsible for cleaning the laboratory, cleaning glassware, do not carry out their jobs effectively, you can introduce contamination to the laboratory, which can take some months sometimes to clear. We tend to forget how sensitive the instruments are that we're using. We're working in half a billion, half a trillion levels. Very, very small amounts of contamination in the laboratory can cause large problems. But there was the last dioxin scare. My laboratory received samples of animal feed that were contaminated with dioxins. We also received samples of milk as a result of feeding animal feed to cows. The levels were so high in the feed that everything in the dioxin lab became contaminated. It was impossible to analyse the milk samples at parts per trillion level because of contamination. It's very easy to contaminate labs. It's very easy to have contamination of laboratory consumables and solvents and so forth. This can add costs enormously when you're trying to get back to low background levels. So I want to just deviate a little bit here. In the introduction, you heard that Vinnie Pyers is managing a resource of the Thermo Fisher called the Food Safety Response Centre. I'll just like to give a bit of background and explain what this is about. There have been a number of food scares in Europe, well everywhere in fact, exemplified by newspaper articles like this. And one of the characteristics of these food scares is that when the newspapers get hold of these stories, government and industry rapidly need access to good methods to use. Immediately there's a scare, there's a requirement to monitor the food chain to find out how extensive the problem is. So there's a need quickly to have methods. And in general, most labs are not well equipped to rapidly generate new methods to use in this area. And Thermo Fisher Scientific decided that they would make an investment to try to do something about this. And the Food Safety Response Centre, FSRC, is the world's first laboratory dedicated entirely to emerging chemical contaminants. This is a lab where the goal is to develop methods for these new scare contaminants in food. It is a flexible staff with a broad range of expertise. This is important because they're not staff that are focused on one area. They've got state-of-the-art equipment, and they're going to provide a focal point of collaboration with the customers. So if there are areas where you feel you'd like to collaborate, then Vincent Pyers is the man to talk to later today. If I was starting my career as a chemist in food safety and somebody said, where do you want to work? I'd say, I want to work in the Food Safety Response Centre. It's got everything that, as a chemist working in trace analysis, you could want. So it's got a wet chemistry that has everything to handle all different food matrix types. And all of the techniques that we've discussed today are available in this laboratory. It also has a state-of-the-art instrument lab, so the turbo flow technique, GCMS-MS, LCMS, LCMS-MS, and in January the high-resolution LCMS will be available to the staff here. So it has everything that you need to do trace analysis in food safety. The staff presently are demonstrating their competence by looking at a range of different existing food safety areas. And the intention is that they should develop generic approaches to handling target analysis. So the idea is that when there's a scare like melamine, this small group of people will divide up. One will start looking at extraction, one will look at clean-up techniques, one will look at instrumental methods, and very quickly they'll bring together a robust method that can be shared with the food safety community. So this is not a facility that's in competition in any sense with anything that's going on elsewhere. It's a facility that's going to be available to help in the event of a crisis by sharing analytical methods. So this is the Food Safety Response Centre. Just coming back to the field, I've discussed a lot the cost elements of running a laboratory. I want to finish by talking about how you maintain the state-of-the-art laboratory. If you're running a laboratory, you can't have the same methods and use the same methods year after year, no matter how good these methods are. You really need to feed the profit from service work into R&D. You need to carry out research work to ensure that you stay at the cutting edge. You need to develop new methodologies. You need to feed the R&D into the service work. And all successful food testing labs have a balance of service and R&D. Probably 10% R&D or 20% R&D with 80% service delivery. But it's more complicated than that. One of the jobs of the managers of the laboratory is to anticipate how technology is changing. So managers of testing with labs come to seminars like this to find out what's going to happen in the future. What are the changes? What are the new technologies? Because if you don't invest at the right time in new technology, you get left behind. So it's absolutely critical to be successful in this field that you maintain your investment in critical technology. So when is the right time to invest in new instrumentation? We talked today about high-resolution LCMS. I believe this is a step change in terms of LCMS, and there comes a point in which successful labs make this sort of investment. You get left behind if you don't do it at the right time. So making these decisions is very critical in terms of success. But at the same time, it's not just these investments, you also need to invest in training and developing staff and new techniques. So investing for the future is about method development of R&D to maintain a competitive position. It's about extending and expanding the scope of existing methods. And it's about assessing and investing in new technologies. So just to draw together both the remarks I made when I opened the seminar this morning and this concluding presentation, understanding customer needs is critical. This is what fit-for-purpose methods means. And I hope during today we've demonstrated to you the wide range of choices of methods, the wide range of choices of instrumentation, because they're all very different, they all offer different advantages and disadvantages. And understanding customer needs, understanding changing demands of customers is really important in this area. In terms of management and being efficient in business, understanding what's going on in the laboratory, understanding laboratory processes, the workflow in the laboratory are critical for the delivery of efficient and effective services. And finally, we need a third leg here, which is maintaining awareness of changes and developments in science to enable you to stay at the cutting